All right, so example 4, we're just going to factor. A says we have 2 sine squared minus 3 sine plus 1. Now there's 2 ways you can do this. You can think of it as, I'm going to split this in half here. So you can think of it like this. You have 2 times something squared, right? So how about 2x squared minus 3x plus 1. I'm going to factor this just like I would have factored 2x squared minus 3x plus 1, which for us we use the alien, right? Remember the alien from factoring back at the beginning of school? Alright, so okay, maybe I didn't call it alien with y'all. Anyways, but so we multiply by the 2. Okay. Multiply by the 2. You get that simple trinomial. Has to multiply to 2 and add to 3. And both of them are negative, right? But don't forget, you got this 2 out here you got to bring back. Reduce it if possible. And if it doesn't reduce, if it's still a fraction even after it reduces, you take the number on bottom and throw it in front of the x.
Just toss it right there.
Now, the only thing is I didn't just have x in this problem. What did we replace x? What did x replace? Sine, right? So this would be sine minus 1, sine of x minus 1 times 2 sine of x minus 1. Now, if we'd have done it without replacement, it would be the same thing. Just everywhere I had an x, I would have wrote sine of x, okay? So you would have taken the 2 times the last number. It have multiplied. You just said simple trinomial. To get sine squared, it would have been sine times sine. Multiplies the 2, adds the 3. You still said minus 2 minus 1. Brought the 2 back. Reduced if possible. And if not, throw the 2 back in front. Or the number on bottom, excuse me, back in front. Either way, we got the same exact answer. So if you want to use substitution, where you just plug x in instead of that trig function, that's fine. But don't forget to plug it back in at the end. Or just do it using the trig function. Either way, you get the same answer. Alright, so let's look at B. So if you like the first way, this would be 16 minus x squared. Just don't forget that when you're finished factoring, you got to replace the x back with secant, okay? So I'm going to try working it the first way. I meant the second way first, though, this time. So we got 16 minus secant squared. How can we factor that? Difference of squares. What's the square root of 16? And what is the square root of secant squared? So remember, it's going to be 4 plus secant of x, and then 4 minus secant of x. Can I factor that any further? No. They're not difference of squares. They're only 2 terms. All right, if you're doing the other way, you would have said the square root of 16 is 4. The square root of x squared is x. So you would have said 4 plus x. 4 minus x. You can't factor it any further, so just replace the x. So 4 plus secant and 4 minus secant. Of course, with x. Either way, we get the same answer. So let's look at C. C has cosecant of alpha minus cosecant of alpha cosine squared of alpha. So what can we do there? Well, we've got 2 terms.
Well, you can change that.
No, I told us a factor, though. So we're not going to switch on that. But what's our first step for factoring? Do you remember? Greatest common factor, right? So do these two have a greatest common factor? Do they have something in common?
They do.
They both have a cosecant, so let's take that out. So cosecant of alpha, remember that means we divide it out, so we get 1 minus cosine squared of alpha. And now we're factoring, okay? So be careful because your gut instinct right now is probably, oops, she told us squared and a 1. Look at our identities, okay? But we're factoring. So can I factor what's in the parentheses?
No.
Yes.
Yes.
That's a difference of squares, isn't it?
X is 1, so we can indeed.
So keep your cosecant of alpha on the outside here. We know this is a difference of squares, so we're going to have 2 parentheses. What's the square root of 1?
1.
And what's the square root of cosine squared?
Cosine.
All right, so we're going to have 1 plus cosine of alpha times 1 minus cosine of alpha.
Perfect.
And can I factor them any further?
No. Yes. Yes.
No. No difference of squares. There's only 2 terms inside parentheses. There's no difference of squares and no sum or difference of cubes. And there's only a cosecant on the outside.
That's a dub.
All right, and on D. What can we do on D?
Let me try to work it out real quick.
Mmm.
You divide the
We
first
need
one.
to figure
Oh,
out
wait.
the
Co-
reciprocal of
Cotangent has one of the cotangent's gonna have a sign in it. Is that a lead? Because you can change cosecant to whatever sign.
You could. And this one's tricky because our directions are just a factor, but there's no way to factor that. They're not like trig functions. No difference of squares. It's a trinomial. It's got 3 terms, but we can't really do anything with it. So let me guide you a little bit here. If cosecant squared, if I could change that into a cotangent squared somehow, then I could factor this.
Oh.
So is there any identity that relates cosecant squared with cotangent?
Sine.
Okay?
Oh, identity. Oh.
With cotangent though,
Oh, no,
not with
no.
just sine.
Yep, there is. Cos. Nope, there's not.
There is.
There is.
Keep looking.
Cotangent squared plus 1 equals.
We go through sine.
If we go to our identities, we'll see, yeah, that cosecant squared
What?
is equal to 1 plus cotangent squared, right?
Wait,
I have cosine.
Oh, yeah.
Not cosecant.
I filled out this homework.
Wait, cosecant squared equals, no, mine
No,
says,
It says cosine.
it's supposed to say cotangent squared.
I have cotangent squared plus 1 equals cosine squared.
It should say cosecant squared there.
Okay, then that's the one we'll use right there.
Right. All right, so we know that cosecant squared is equal to 1 plus cotangent squared.
Oh, you know it.
And then I have my minus cotangent of beta minus 3. Well, before I can factor, I've got to obviously combine like terms. So I'm going to add my 1 and my negative 3. So I have cotangent squared of beta minus cotangent of beta
Minus 2.
minus 2.
This is an easy dub.
This is a simple trinomial.
You know it.
So cotangent squared, so we know it's going to be cotangent and cotangent.
How does it equal 1 though?
What multiplies it 2 that will subtract to 1. 2 and 1.
Oh, I was putting cotangent of b.
And we know it's going to be a minus 2 and a positive 1.
Yep.
All right, this one wasn't one where we multiplied at the very beginning, so we can't factor those any further. So there's our answer.